Okay, cool. Suppose Leetcode will start its IPO soon. In order to sell a good price of its share to venture capital, Leetcode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, it can only finish at most K distinct projects before the IPO. Help Leetcode design the best ways to maximize its total capital after finishing at most K distinct projects. You're given several projects. For each project I has pure profit P sub I and a minimal capital of C sub I is needed to start the corresponding project. Initially, you have W capital. When you finish a project, you would obtain its pure profit and the profit will be added to your total capital. To sum up, pick a list of at most K distinct projects from the given project to maximize your final capital and output your final maximized capital. Okay. My initial intuition is that that is this is similar to a sort of knapsacky type thing, except for you could actually have more capital afterwards. So maybe not. Let me think about it. Okay, let's look at the example. Who's this guy? Since your initial capital is 0, you can only start the project index 0. And then that's one of project 2. Since you can finish at most 2 projects, okay. Let's take a notes. Okay, so at most there's 50,000 projects, and the answer is guaranteed to fit in 32-bit signed integers. Okay. I think my initial kind of thought is whether greedy makes sense. Because for greedy solutions to work in general, you rely on each substructure of or subproblem to kind of have have already contained the optimal substructure. But and for me, as I mentioned before, I usually have trouble convincing myself that this is the case. But I think that maybe this could be it. But I'm also trying to right now. My daughter's trying to figure out if I could kind of visualize this as a graph problem. Because if you with a graph problem, then and then there are graph type solutions depending on the problem. Let's see. I'd like to let me double check the question to see whether issue you have W capital. Actually, I think my initial assumption may or may not be right. I think the thing that I'm trying to think is that in general, I mean, that's why sometimes with these problems it's a little hard to kind of understand. Like some problems put you in a disadvantage if you have some understanding of the real world because they might not mention it. But in this case, for example, it's actually because my initial intuition would be that starting with W capital, after you finish a project, you actually end up with W minus P of, W minus the cost plus the profit, right? Like kind of like a delta thing. But it seems like that's not the case, actually. It just seems like every time you look at each of these projects as having a requirement, and for each when it satisfies it, you can do it, and then you just get the profit on top. So I think that's okay. I think in that case, it's seems to be okay. Let's see. So I think so another thing I'm trying to think about is whether, to be honest, this is a little too easy if it's greedy. Because there's still a hard problem. So maybe I'm just, I'm just trying to think maybe a little bit too meta about this. Because I think there are two parts of the problem, right? Or two questions you're asking yourself. Maybe I'll do Python because Python 2 or Python 3. Okay. So there are two parts of the questions that you have to ask. Is one is at any given time. So okay, let's make the assumption. This is my greedy algorithm, and or me trying to do this greedy. For that is that for every given time, given a current W, what projects can I do? Right? And then given, and then the second part of this is given a set of projects, how can I make the most capital, I guess? And I think in this case, why I think greedy works is that there's essentially no penalty for picking there's essentially no penalty for picking the most profits, because the most profits just allows you to even open up more capital, right? Like if you do something that has the most capital that you can do, most profit. So because there isn't a case where like you choose a project and it leads to a suboptimal solution later on, because the more profit you make, the more like it's almost a superset of having less profit. Like in the example in this case, if you pick the 2, if you pick the 3 instead of the 2, there's no possibility that allows to, or like you can like there are no more additional decisions that the 2 will allow you to have that the 3 doesn't have. Like the 3 is strictly better in that case, right? So I think that's why it leads to my 2 kind of questions, and I think so. Okay. Okay, so how do we want to solve this, right? So n is at most 50,000. So I think that we could solve this by having 2 priority queues. I think that's how I would kind of figure it out. And what that mean? What is that? Why? So I think I have 2 priority queues, so that I could have, say, the first, that 1 PQ to manage what projects I can do, right? So in this priority queue, you have a priority queue to contain. I think the guy next to me lost in Counter-Strike. But okay, so you have a counter that's sorted by capital. So in this case, there'll be a min first PQ sorted by capital, and every step of the way we pop until we can no longer afford what's on top, right? And then you have a second PQ to manage what project to give most profit, right? And then this priority queue, this priority queue will be sorted by profits. In this case, when we pop, we insert into the second priority queue. Okay, and the second priority queue will be sorted by profits. when we pop, yeah, we just take the project's money, right? Take the project's money. I think that's roughly how I would do it. Yeah, okay. I mean, I think this should be relatively straightforward. If we have a good party queue, and in and a priority queue is just a heap in most languages. I actually haven't done this in a while, so I'm going to just do a quick Google on Python and heap, Python heap implementation. Okay, heap queue. Okay. Oh. Am I in Python 2? No, I'm in Python 3. Okay, so there's heap. I actually don't know that I've used this, but okay, pop in between the smallest object. Okay. Oh yeah. Sorted by most profits, to be clear. Okay. So let's say for K, for K, this is Python 3, so there's no X range. So this means for each K, we iterate this, right? I guess we have to initialize first. Okay, first we have the can do queue. Let's just call it can do queue because I can name stuff today. So you go to heap queue. Now this is just a heap queue algorithm. Okay. Okay, so you just give it an array, and I guess it just does it for you. Maybe that's better. And then we put everything into the. Okay. Okay, so we have two arrays. So okay. They want to use zipped. Okay, so I forget. Just want to double check the syntax. Okay. Okay, seems like that's what. So for item and zip profits, capital. Okay, let's just print this out first. It's been a while since I used these stuff, so these are.
О, блядь, я тупо тайм проебал. А, да господи, Дима.
Блядь, ладно. Видишь, там вот дома посередине.
Да.
Make sure this does what I think it does. Okay, that looks okay. So now we have these items. So can do queue equals. Oh, just wait. That imports some.
Машина есть хоть какая-то?
Yeah, these examples does not tell you what to import. Or maybe I just really bad at reading.
Машина есть у тебя какая-то?
No. Actually, I also don't know how if I'm supposed to import stuff in Leetcode because it seems like things just work magically.
Беги, подай мне попробуй.
Okay, whatever. Maybe that's not quite right. We'll see. So we want to hit push. The tuple can do queue. We want to sort by capital. So let's say maybe we should use name tuples or something like that. And just for my sanity, we'll print it out the pops for. Okay. Well.
Тут чувак. Я просто бегу в ебаный У меня в домах, да, я бегу.
Бежишь в руины?
Да, потому что... в тех
Okay,
желтых
so he
домах
pushes
было,
not defined. I,
никого не было. Я такой
how do I
бегу,
use this?
и вижу его, и разворачиваюсь. Я не знаю.
I know how heap
Иди тоже
push
в руину, пробуй,
works.
что угодно. Мы типа в зоне.
So it does seem like.
Блядь, ты туда.
Am I misspelled this? Hip Q. Nope. Heap element must be a list. Yeah, I'm not implementing my own heap. I mean, that is just silly. I mean, look, if you want to watch a stream of someone implement their own heap, that's fine too. Oh, that seems like that's okay though. Well, I mean,
Нахуй, блядь, я больше с тобой, блядь, выполню эту цифру. Левай.
no, that's not right. Oh, whoops. Heap argument must be a list. What does that mean? Yeah, spending a lot of time doing language stuff, but push. Oh, I guess after the first one, it became stopped being away. Okay, so okay. So that looks hippie, right? I don't know if that's actually true. Or it's just returning stuff. Okay, let's just assume that's right for now. Okay. Okay. So now, where's my other thing? So we pushed on the can do queue, right? And now we want to pop all the ones that we can afford to pop. So is there a peak? Or just there's no peak. And smallest. I guess you should prefer a peak, but okay, fine. I guess just one, right? Heap q dot and smallest one and q peak item. Wait, did I spell peak wrong? Nope. I mean, maybe still yes, but okay. So look at peak if this should probably be a statement somewhere. But wow, item. Peak item. Should use name tuples next time, but so that should be now the capital is the front. Okay, can't is W. So then we add it to a second queue, which is where we set most profit queue. Okay, because now we could take a look at this later.
Блять, 2 квадрата мы до ясны бы дали. Квадрат. Ну да.
Why do they prefer n largest and n minus? N largest and n smallest.
Не, мы тут ближе.
Okay, so I guess we don't even.
Не, мы сюда летели почти 2 квадрата. Бля, людей дохуя.
Okay, fine. Well, actually, no. The complexity of what they implement, so maybe this is a little weird. But okay. So we push this and then peak item.
Ну,
Let's see.
2 чувака вижу рядом относительно. Поздно выпрыгнули.
Oh, and with the pop.
Это АФКшник. Один рядом со мной. Как надо мной где-то. Один в желтые полетел в дома. В желтые над берегом, знаешь, там дома. Одни полетели на болото.
Okay.
Полетел, короче,
So this should move all the things there, and then we just need to pop up one item. Okay. Yeah, so.
Если ты, блядь, пролетаешься лучше, чем меня, блядь, все домов там меньше.
Yeah, we don't need the item there. Okay. Pop. Actually, that may be a little tricky. Yeah, okay. Because we want the largest and not the smallest. Wait, are these all positive and okay? They're all non-negative. Okay. So this will. If we put the same thing here, we actually want to sort by something else, right? So first of all, let's put this down. So in theory, we have something like this, but where the zero index is the capital, and this is the one index is the profit. So actually, we want to sort by the profit, and we want to do it negatively so that because it automatically gets the smallest. So okay, now he pop of most profit queue. Okay, I'll just say this is the right. And then W item of the profit, and this is negative, and we reverse it again. Why does it go? Or am I missing a thing somewhere? Yeah, I am. Okay. Yeah, that maybe should be okay, but let's print this out because I have to, don't really believe it. But right, let's see what this returns. Double and inch. Oh, why is this a double? Oh, because this is okay. Again, what? Man. What does n smallest return? Return a list of the n smallest. Okay. This should already be an item.
Блять, я сейвлюсь нахуй.
Oh, so one. So that should be. Don't get it. Yeah, so what am I? Is W? No, W is an int.
чувак на улице, тут чувак на улице, тут чувак на блядь, он меня положил, выйти на улицу, просто вон там вот чувак. Вон.
Ты уже его положил. Пойдешь ко мне?
Блядь, я пишу с моим под забором, блядь, сидит. Сука, как дебил начал стрелять.
Смотри. Я слышал. Ну, блядь, я
That is odd.
с миника, с вектором позже. Ну, вектор вообще жесткий.
Не, он меня не продал.
Я тоже не понял. Куда он?
What is that? What? So what is the? It's W. W is just.
Тебе жопа надо на своей.
Да, надо. А еще потроить.
Бля, я вам гораздо
What?
Я в этом не
Is W a double? Did I mess something up?
Говорим, пришли. Там 10 чувак стреляют, я что-то вижу и
What is going on?
у меня на руках. Тут кульки, короче. Нет. Пятерок нету, семерки собирай. А, Харя, привет.
It is very weird with error that I'm getting. Oh, I forgot about mouse.
На жопу. На вот это нет.
Where's the tuple?
Коллиматор надо.
Okay, this is actually a little confounding because I don't know. They both should be int, but
Нет, не да. Мне зум надо.
I don't even know what to print to debug this. What? Am I looking at the wrong line?
Спасибо. Да.
What language was I using? Wow. Now I'm just confused because even the print returns true. Is this pointing at the right thing?
Пошли вот эти желтые давно, потом там чуваки на болоте были. Он здесь будет.
Oh, I see. Maybe the next item is.
Пятерок нет.
Oh man, what a dumb mistake. Okay, so this should be 0 too. Okay.
Запасили вообще.
Yeah, index is up there. Okay. Yeah, this is probably safer. That's why we check to see whether it's none or not. Okay. Well, oh,
Проверь, все равно по-любому что-то. Не, у меня есть.
Я понял. Семерка.
hmm?
V3. One more need.
No more.
Yeah, one more need.
You can maybe create.
Просто я знаю, вот
Wait, wait.
бустик, ракетница.
Серьезно?
Да? Омегаз, надо на это.
Газ надо.
Ой. Компас, аптечка.
I mean, I guess that's fair,
Сколько у тебя
but
аптек?
what does it return?
На,
I mean, it
вот.
has to be not none,
Много
right?
еще делаешь.
Does it just be, okay, fine.
Как ты что собирал?
Дальше? Или куда? На кого
Вот сюда.
ответил?
Не, вот я поставил. Ну ладно, давай вот эти за этим, потом на метку.
What is going on?
Возьми вот она. Тут аптечка забери.
Oh, man.
Сколько тебе сколько?
Сейчас.
Маленький, большой? Ну, у меня 6 маленьких, поэтому я сейчас дам.
Дай.
Ответ X4. На.
Okay.
Да. Мне
So
60.
that seems okay. So the first pop, it gets the one with the 1 profit, and then it gets the 3. Okay. I mean, I'm relatively happy about this, despite a lot of my minor getting around the library and syntax, and this is why you practice getting used to know the thing. But let's see if let me try a couple more test cases. For example, let's say there's just one that you can't get to, which is
Развернись на метке.
okay. It still should be the same. Let's say, let's put one in the front just in case some ordering thing matters. Actually, though, this should change because now you can do 2 and 25. All right, just gonna submit this, and then probably some. Oh my God, index error. Man, really, seems like people here started smoking, so that's my cue to hurry it up. But
Приоритетно вот сейчас вот я дам проверить. Буду
probably missing something silly. I guess this is the case where there are no items. Is this actually what? Okay, fine. If most profit Q.
Не переедь.
I think I should. I think this.
Близко у меня.
Блять, меня вырубили.
Замри.
Oh my God. What? Sorry, the smoke is a little distracting, but yeah, I mean, I think this is definitely an edge case that I should have known about, which is that you can't do anything in the beginning. This is what it should tell you. And time limit exceeded. Huh. So now that's actually somewhat surprising, but what the hell? I mean, my only guess is that the n smallest is actually not a pop, or this is why I kind of wanted a peek, but I guess n smallest actually does a sorted on it, so that's actually not great. Push the item in front of Poppington. What? Okay, well, nothing I can do, I guess. So okay. So what happens was this is way too inefficient. In some language where you have a peak, you could actually just take. I guess if you do it that way, maybe we could just take a look at the first item. Well, I've been trying to use this as an abstraction, but I forget that we have access to the underlying data. So, Actually, in this case, we actually can just pop. Okay.
Не знаю.
My God, this is meant to be copy and paste.
Два прям передо мной.
Yeah, that is intense. All right, let's see if I could copy and paste this. Okay, so that fixes it. Okay, so that solves it. So I think the main point here is kind of, well, one, as you know, a viewer point out, kind of, is that be familiar, be familiar with the library. I think on this is actually, I think, a very reasonable interview questions. There's only two. You take one kind of very basic data structure in the priority queue, and then kind of use it in a creative way by using two of them. So I could definitely see this in an interview. I would say, yeah, be familiar with the language, and maybe for an interview, they may ask you how to implement heapify or just like heaps in general. I would actually, yeah. I think I'm more familiar with C++ stdq, so I think I was thinking along that way. But definitely, what I've done here seems sufficient, so I'm happy with that, and it passed the test. I think going back, this is essentially a greedy solution. I still don't really have a good. I think a lot of greedy solutions requires you to prove to yourself that for each step of the way. There's the sub problem is already optimal, and that there's only one way from each of the one of the pathways that you go back and do the same greedy assumption. And the reason why I think that this was a good candidate for that is that because if you go back to the description. I think I mentioned this before, is that given a profit, because given two equivalent projects, you always want to choose the one with the more profit because it only leads to a superset of options that are open to you. Where in another case, you can imagine you use the one with the two. With the two profit, but then you cannot use three in the future, something like that, right? Where there's some kind of exclusion, then I would really have to think about the right way to go about it. Okay.